All right, ladies and gentlemen, welcome to your Chapter 5 video notes. This particular video is going to cover Chapter 5, Section 2, a specific skill called synthetic substitution. Again, these are based on your McGraw-Hill Algebra 2 textbook. We are talking about synthetic substitution. So before we get into that, got a little bit of vocab. When we look at a polynomial, that polynomial will have a degree and a lead coefficient. So let's say we were looking at something like this. F of x equals 3x squared minus 5x plus 1. The lead coefficient is the coefficient with the largest exponent. That would be this coefficient here is 3. The largest exponent of that problem is 2. Which would mark 3x squared as being called what is known as the lead term. Degree is the largest exponent, so in this case the degree of f of x would be 2. And then we're going to talk today about a simpler version of substitution called synthetic substitution or synthetic division, depending on what application you're doing with it. So let's get down to business. If we have f of x equals 2x cubed minus 13x squared plus 26x minus 24, as we do here in this example, and we want to know what that function's value is when x equals 4, we used to plug that 4 in for all the different x's, and then we'd cube it, square it, whatever we needed to do, and add them together. There's just a lot of opportunities there to make errors. There's a lot of places where we can mess that up. On the other hand, if we use what is called synthetic substitution, all we're doing is adding and multiplying, which simplifies the work. So here's how this works. We draw a box, and in that box we put the function value that we are evaluating at. So if we want to know f of 4, we put 4 in that box. Okay? Outside that box, we're going to list the coefficients in descending order of variable. That would be 2, negative 13, 26, and negative 24. We do not need to include the variables because we're doing sort of a shorthanded version of this. Leave one line worth of space because we're going to be writing some numbers in there, and draw a line. And then underneath your last column, put a box. So it should look like this every time. Now the process is relatively simple. We take this first number, whatever it is, and we bring it straight down. We do not make any changes to it at all. We then take that number and we multiply by 4. This is your multiplier. So we do 2 times 4, and we write that number underneath the negative 13, so that would be 8. Then what we do is we add straight down. So negative 13 plus 8 would be negative 5. And we basically just repeat those steps over and over again. So we take negative 5, we multiply that by 4. That would be negative 20. We write that underneath 26. And then we add straight down, which would give us 6. Then we multiply that by 4. So 6 times the number in the box, which is 4, is positive 24. And then we add down. And we get 0. So what this tells us, this number in the box here, tells us that f of 4 is 0, which would also be written as the ordered pair 4, 0. So whether we want it to be in function notation or written as an ordered pair, this is how we carry out synthetic substitution. So let's do some more examples. We've got 2 more here. It says to use synthetic substitution to evaluate, write your answer as an ordered pair. So again, we're going to put the number in the box that we are evaluating. So in this case, negative 1 goes in the box. Okay, that number goes here. And then our coefficients from our function go outside the box. So it would be 2, -6, -1, 3. We leave one line of space, and we box off our last column. Bring that first number straight down. 2 times -1 is -2. Add down, -8. -1 times -8 is +8. Add down is +7. -1 times 7 is -7. Add down is -4. So that tells us that f of -1 is -4, which implies the ordered pair -1, -4 would be our answer. On the next one, we put 2 in the box. Again, we take the number that we're being asked to evaluate at, and that goes in the box. Outside the box, we put our coefficients. 3, -8, 11, -14. Leave one line of space and box off that last column. First number comes straight down. 2, the number in the box, times 3 is 6. Add down is -2. 2 times -2 is -4. Add down is 7. 2 times 7 is 14. Add down is 0. So f of 2 is 0, implying the ordered pair 2, 0. Okay, so at this point, what you should do, well, let's do a couple more examples first. Here on letter C, there's a trick to this one, because you have to notice that there is no x squared term. Every term in a polynomial is required in order for us to do the problem. So since there's no x squared term, the first thing we have to do is mentally we have to realize that we need to insert a 0 for the x squared term, because in order for this process to work, every term has to be there: x cubed, x squared, x, and the number. So into the box, we're going to put -3. Outside the box will be the numbers 1, 0, -4, 19. 1 comes down. -3 times 1 is -3. Add down is -3. -3 times -3 is 9. Add down is 5. -3 times 5 is -15. Add down is 4. So f of -3 is 4, which implies the ordered pair -3, 4. At this point, if you think you got it, you should pause the video and try letter D on your own, and then resume the video to see how you did. Letter D is also missing a term, so in your head you need to realize that f of x needs to be written as x cubed minus 2x squared plus 0x minus 3. In the box is going to be 3. Okay, we always take that number we're evaluating, and that's the number that we put into our box. So 3 goes in the box. Outside the box go your coefficients: 1, -2, 0, -3. Bring that first number straight down. 3 times 1 is 3. Add down, that's 1. 3 times 1 is 3. Add down is 3. 3 times 3 is 9. Add down is 6. So f of 3, you should have gotten 6. That is the ordered pair 3, 6. All right, I think we only have 2 more examples here in this lesson. So again, if you haven't done so yet, you should pause the video and try those 2 examples on your own, and then resume the video to see how you did. On letter E, we're looking at y equals 4x cubed minus 3x squared plus x minus 12, and I just realized that there is not anything missing there. So we're going to put 2 in our box, because that's the number that is x equals 2, so that number goes into the box. So we're going to put 2 in the box. Outside the box go your coefficients: 4, -3, 1, -12. Bring that 4 straight down. 2 times 4 is 8. Add down is 5. I forgot to put my box. 2 times 5 is 10. Add down is 11. 2 times 11 is 22. Add down is 10. So when x equals 2, y is 10. That implies the ordered pair, 2, 10. Finally, on the last one, we're missing an x squared term, so we need to, in our heads, realize that we need to use 1x cubed plus 0x squared minus 2x minus 4. In the box, we're going to be putting 2. So we put 2 in the box. Outside the box go our numbers, 1, 0, negative 2, and negative 4. Bring the 1 straight down. 2 times 1 is 2. Add down is 2. 2 times 2 is 4. Add down is still 2. 2 times 2 is 4. Add down is 0. So when x equals 2, y equals 0. That implies the point 2, 0. That does it for lesson 5-2. Thank you for your time and attention. I hope you find these videos helpful.